Hello everyone, welcome back to the AI Agentic Mastery course. In the previous sessions, we learned about the evolution of Gen AI to AI agent and then full-fledged Agentic AI. In today's session, we will start with that hands-on experience to build an AI agent using the Python codes. It's small but a very powerful code. It learns the query, make a decision, take action, and then give an intelligent result. Apart from that, we also learn about the core capabilities of Agentic AI, its internal architecture, its benefits, its challenges, and the different design pattern that you can use to build your own Agentic AI ecosystem. Okay, so let's start with building an AI agent. So this is the code that I have already built. So I will walk you through the code. Before walking through the code, let me give you a brief idea what exactly this code is doing. So this is a code of a AI agent which answers the query of a user and give you a response. So as I said earlier, so AI agent is built to achieve one goal. In this code, so what we are doing is we want to achieve a goal. So if a user asks a query related to a weather, so it is a weather agent, so it give you answer. You have seen like what is the current weather in the London. So this is the query. Okay. So I hope you have a basic understanding of the Python. So, but I will try to explain as much as possible. So this is the starting point of a Python program. So as you run the program, the control first go here, and you can see I have sent I have just put a query like what is the current weather of London, right? So actually it is a query which we are asking to a AI agent. So before going to the deep dive, let me first explain what exactly is written in this code. So there is one method. Method means that it's a function. So this function is doing all the agent stuff, right? This is the AI agent. So all of the code related to AI agent is written here, and so this is a tool, so which this actually is a function, and it calls an API, and you pass an API with the API key and the city name, and it will give you the weather of that. So it is just a normal API call. Okay. And so this is a tool map where I have mentioned that as of now there is only one tool. So you can see that there is one tool I have defined here. So this it is a check weather tool. So what exactly is that? It's a mapping of a tool. So we name it as a check weather. So when AI agent will identify a tool named check weather tool, it call this method. So internally it will pass this parameter. Maybe in our case, it's a London. Call the API, fetch the result of London, and then give it back. So this is the mapping, tool mapping, and this is the this name can be different from the function name. Okay, so here the mapping is done in the tool map. So in this function, we'll specify how this identify how to call this. Okay, and specify the description like this function gets the temperature and the sky condition of any city which you pass, and there is one parameter. The name of the parameter is city name, and it is type. Its type is string, and you can description is just the name of the city. So, like in this case, I give an example: London and Tokyo. It doesn't mean that it will give the answer of London and Tokyo only. You can pass any city. Okay. And here I have also mentioned that it should be a required parameter. It's a mandatory to pass the parameter. So now this is the system prompt. Like for agent, we are saying to an agent like you are an expert weather analyst. You must use this method, this check weather tool, for to get the all weather related queries and then give the friendly response. Okay. So this is what we have done, the basic background of AI agent. Like we define a schema, we define a mapping, and we also created a one tool which called the API to get the weather. And then there is a system prompt that we are saying agent that what the agent has to do. Okay. So now coming to the main heart of this AI agent. Okay. So now this is just the description, like runs the full agent. And as I said, that agent first understands the query, then uh, make a decision. Okay, plan, make a decision, and then perform an action. After that it give you a answer. Okay, so here we have defined, like as of now it's at phase 2, but internally it is a phase 3. Like it reads the query, and then take the action, or sorry, take the plan, create the plan, and execute, and then give the response. Okay, so now here we have written in the response, analyze the data, and then give a friendly summary. Okay, so this is the output now. So this is the history that we have said. Like role is system is it's a agent response. Okay, and the user, it's a user query. So here I just pass this information. It's a kind of a memory. Okay, as I said that AI agent will have three things: memory, LLM, and tool. Okay, so we have defined memory here also. So it can be any memory, as I said, the short-term and long-term memory. So this is a short-term memory. This is for one conversation only. And we have also defined a tool. Okay, so what is left is a LLM, right? So here we have defined, like this is the model for GPT-4. Okay, so I forgot to mention that. So we have passed these OpenAI. We have imported. There are basic requirements that you have to do. Like I just created, like you know how to create a environment, and then we installed the pip libraries like OpenAI, Python dev, and request. Okay, so this I think written twice. Okay, so we have imported the OpenAI. .NET App is because all of these configuration of OpenAI key we have specify in the env environment. So why we put it in env? So that it should not be exposed in that code. Okay, so we have defined the API key of weather, because this tool will call the API. Okay, and then API needs a key of that weather. And then the OpenAI, I have again passed the OpenAI key, which is passed in that env file. So how it loads? It loads by using the load env method. Okay, so this is the .env. We imported a .env, and that load.env imports all the variables which are defined in the env file, and then we saved it in this variables. Okay, coming back to here again. So as I said, we are using OpenAI, and the model is GPT-4o mini. So now three things are covered here for AI agent. Model means LLM. We have defined OpenAI, and this is the model. Memory, and that tool, which tool we are going to use. Okay. So now what will happen is, as I said, that we call this method and we pass the query. Okay. So we pass the query here in this method. So user query. So this is the query that is also saved in that memory. Okay. And where we were. Okay, and now what we are doing is here we pass this conversation. So this conversation will have the user query also. Okay, tool is also defined, LLM is also defined. Now once we pass this, then the role of agent will start. Okay, so it first understand the query. Okay, what the query it is. So it is written like what is the current weather in the London. Okay, so it understands the query, and then okay, understand, okay, this tool I have to use, and this is already defined here. So means I have to pull a city name, because there is a parameter and it's a mandatory. From that query, it understand and pull the parameter. Like in this case, it is a London. And now it understands I have to use this tool. This is the query. From that query, it has identified the parameter like city. Okay, so now agent understand. Now it knows like from this tool, it understand I have to call this method. Okay, so then he knows now query is objective is defined. I understand the query, I fetch that parameter, I know this method to call. Okay, so this is a method that I have written. Like if you pass an information which doesn't have a mandatory parameter like city, if you pass like a hello, then it will definitely it will not have any tool call. Then it will give you as just a generic response. It will not give you a kind of weather of blank city. So it will give you, so I need this information. Okay, I need this city, so you please pass the city. So if function is identified, then what it is doing is it now adding it to the history. What is the thought that is coming? Like I have to call this method, I have to use this city, and I have to use this model. Okay, and then we'll call that. So now in the every planning phase is done. Okay, so this planning phase is done. Now next is the action. So in order to do the action, what it knows, what it should have is the function name, okay, and the parameter. Parameter is a city. So now in this case, it is executing the function name and the parameter. So here it is a tool map, like I said that the name of the function and the actual function can be different. So this is the tool mapping is done. So from this, it checks, it's a kind of a dictionary. It checks, okay, I have to call this method. So here it is checking this method. Here tool map. Now it has the function name. It call the function name. It call the API. API gives the response and will get a result like what is the weather of whatever the weather of that London at the time is. It will give you the result. Okay, then it add the conversation. It add the result in the conversation. I called this so I called this function, and this is the output. Now it get the output from the API. So this part is done. It understand the query, it execute, it created a plan, it execute the plan, it get the result. But as I specified here, analyze, and then the data and provide a concise, friendly summary. So, because the API will give you the 38-degree temperature or whatever the temperature is, it will give you the temperature, okay? But we have to give a response in a friendly manner. So in this case, the final response, again, I am calling the LLM and passing the history. And LLM, it is the, now LLM is doing what it is doing, whatever you're passing, it is just creating a friendly message. And finally, it is giving the final response. Okay, so let's execute. So in order to execute that, I just execute Python main.py. Okay, and here you can see it is calling. Now phase one, agent decides, check weather tool for London, and then observation executed. Result is current temperature is 9.03 degree and condition is sky. So this is the result that we got from the API. Now agent has to give a friendly response. Here again it called the API, oh sorry, LLM, and it is giving the response in a very concise and friendly manner. So this is a complete code of building an AI agent. It's a very simple code, okay? And in this case, we have used OpenAI, okay? We can use any kind of LLM. Okay, so let's understand the agentic AI architecture, and these are the six core capabilities, and whole architecture is based on the modular intelligence. So I have segregated the first four part into the functional and cognitive way, and also the design and architecture way. So like perception and understanding is a functionality, like it's a cognitive functionality of agentic AI. But in terms of the architecture, it is a perception. Okay. Similarly, reasoning and planning is planning, action and delegation is action, reflection and learning is memory. Collaboration and security is an important component because since agentic AI is a multi-model or multi-agent architecture, okay, so how these agents interact with each other is a kind of a collaboration, and how you can set up a security so that there should not be a data leak. That is also maintained the security. Let's go each of them one by one. Perception module is a kind of a sensory system, like a human being has a five senses. From human captures the data, right? So it's a perception module of agentic AI, captures the data from the surroundings. The surrounding can be your camera, your APIs, your database, your text, PDF, any kind of the external information that agent captures is a perception. Okay, then once it captures that, then it transfers these information. Some of them are unstructured. Okay, make it as a organized and convert into the information. So like it's captures the data, understand, transform into a information. Okay, so next is reason and planning. It is also called as a cognitive module. So this is the most important part of agentic architecture. Okay, because it is also called the brain of agentic AI, because all of these decisions and planning is done at this module. Okay, so how it works is it reads the data which perception module has captured. Okay, and understand by putting some reasoning on that what exactly data is doing. Okay, finally deduce it, like draws the conclusion from that information, and then design that. Design means it creates all the possible actions or plans that it can do with that information. And from the multiple plans that it has created, so selects the optimal plan, like from multiple plans that it generates, selects the optimal which is the best fit, and it aligns with the objective. So in nutshell, it is the brain of agentic AI, because from the perception module, whatever the information it has captured, it do all the activity here. What generates the plan, find the optimal plan, and then converts the plan into multiple activities. Okay, so let's jump into the next one, which is the action and delegation. So as plan is generated, activities are also created in that cognitive module. So now next is perform that action, or because there can be multiple activities. Okay, and as I said, agentic is a multi-model. Okay, multiple agents are participating in agentic AI. So maybe in a plan we may have 100 actions, or maybe 20 actions, or 100 actions, or 200 actions. So each action may be done by a specific agent. Okay, so it gives the execution, like after the decision is done, then it delegates also, like this action has to be done by this agent, and this action has to be done by this agent. So all of this, it is done at this level. Okay, so like in some cases, if API is required to be called, like maybe we have to pull the data we have to pull the information from the database, or maybe you have to call the LLM, or maybe you have to call the APIs. Anything, any action will be done at this level. If there are dedicated agents are there, that actions should be delegated to that particular agents. Now let's talk about the most important and powerful capability of agentic AI, which is a reflection and learning. So unlike traditional AI agents which perform the task and stop, but agentic AI After performing the task, it analyzes its own performance and also identify what went well and what went wrong, and then learns from the experience, just like a normal human being which completes a task and then understand and analyze, could I have done it better or faster. So it agentic AI does the same thing but automatically. So it checks the its outcome and compare with the objective. If it is not optimal, then it changes strategy for the next time. Okay, so next time it changes strategy automatically. So it's a kind of a self-learning module. So another key capability of agentic AI is a collaboration. Again, unlike traditional AI, which perform tasks and stop, so agentic AI systems are collaborative by design. They can work together with other AI agents, human, or other system to achieve a complex goal. So imagine a company with a multi-agent system where one agent is doing a data analysis, other is doing scheduling, and third is interacting with the customers. Okay, so they are sharing the context, the data, and the learning with each other. So collaboration is what that makes AI agent a complete team player, not just tools. They become an active partner that can coordinate, cooperate, and co create with others. So let's talk about the security. Security is an important part of agentic AI system. Okay? So when we build an AI agentic system, security is not just add-on, it is an important part of the component. It is a core design principle. These AI agents have access to data, tools, and even the decision making. So it's critical that the actions are ethical, safe, and authorized. So security in AI agentic works on multiple levels. Data security, making sure that AI agent share the data which is protected by data encryption and security controls. Operational security, to make sure that AI agents cannot misuse the tool or take unintended actions, especially when they are working autonomously. And this is important when the agents working on industries like healthcare, finance, where data security and the data privacy is non-negotiable. So when we talk about the challenges in agentic AI, so there are few challenges that I have listed it here. So one is a planning complexity, like it does the planning, but internally what it does that and how it reaches to the conclusion, that is kind of difficult to understand internally what it is doing internally. Okay, reflection goes wrong. So as I said that it learns by their own outcomes and then change its strategy for the next time. But sometimes it rethinks things and rethinks and takes a long time. That sometimes takes a very long time and sometimes becomes a kind of a continuous loops. Okay, so which degrades the performance of the agentic AI system. Tools use reliability as I said that the depends some agents depends or most of the agent depends on the external tools like APIs or other environments. Okay, so if API is not responding or maybe it's there are some latency issues in the API, that can become one of the challenge in the agentic AI. So the next is the memory management. So as I said, it manages the long-term and short-term memory, and sometimes uh, agents automatically hallucinate from the historical memory. Also, it gives the wrong result because of the hallucination. Okay, and multi-agent coordination is as there are multiple agents working together. So sometime is happen is one agent is expecting outcome from another agent, and that is still processing. So some kind of a coordination mismatch may happen in that multi-agent or in the agentic AI system. So security concern is a very big concern. So it should be designed in such a way so there should not be a kind of a data leak or the data should not be exposed. So like if a user doesn't have access to one particular type of data, so then even if the user asks queries related to the data, it should not expose that data. So let's discuss about the Agentic AI design pattern. So these are the design pattern like reflection, tool use, planning, reasoning, the React, we call it the React reasoning and act, and the multi-agent. Most of the things I have already covered, but I will walk you through of each of the design pattern very quickly. So if we talk about the reflection pattern, so it learns from its outcome, iterate and refine its response through introspective feedback loop, and then again enable the agents to pause, evaluate the past decision, adapt, modify, and the future plans, and then learn from the past experience. Okay. So next is tool use pattern. Again, it use the external tool or multiple tools, not only one. It can be a multiple tools and pulls the information from that tool, generate the result, and then perform the action or use the LLM. So again, this is one of the pattern, but in Agentic AI, we'll use a multiple design pattern. So one of them is a tool use pattern. The next one is a planning pattern. Again, it's a cognitive module, like we discussed. It from the perception, it analyzes the data, splits the plan into multiple activities. Even from multiple plan, it choose the optimal plan, and then from the optimal plan it distribute the plan into multiple activities, and then again delegate the tasks or the activities to the other agents or perform by their own. So this is a planning pattern. So next one is a react. Again, it's a almost the same thing, like in the previous one it's a planning, now it's a planning and action, performing action also. So these are the basic pattern, but once we start building that, we combine all of them design, but it's not like we build an AI agent by using one pattern, so we use a multiple design patterns. So this is how it works. So this is the iterative, like first is agent perceive. Again, the perceive means it's captures the information from the external environments, that can be any kind of data. Okay, then again analyze it, generates multiple plan, and then finalize the which one is the best fit. Okay, and then from the best fit plan, uh, distribute the plan into multiple activities, execute them. If it is a multi-agent, then delegate them, and then analyze the results, evaluate, and if self-learn, if they have to change the strategy, change the strategy. So this is how this React works. Okay, so in multi-agent also, so again, like every agent has a particular task. So one agent is a kind of a master that will do the planning and then delegation. So research agent will do the research. So there can be multiple agents. So there, in this case, there are one is a coordinator agent which is interacting with all of these agents. There are two research agents, one task executor agent, and one is a problem. So it can be a multi-agent model. Okay. Okay, so see you in the next session, which is a very important lang chain, and it will be a very interesting session. Okay, so I will come with some codes and will walk you through the code. So all of these next sessions, all of these sessions will be a practical sessions. So I will make sure you will enjoy all of these sessions. Okay, and also learn, so that I will try to explain in a detailed way so that you can also build your AI agents. Okay. Okay. And again, don't forget to subscribe so that you can get update whenever a new video is uploaded.